what's up? Welcome to the last section of our solid state. In this session, I will be explaining you about magnetic properties of solid state. So let's start, and this is the last part. Okay, let's go ahead. Now, magnetic property. So we know that every substance has some magnetic property. Now, the origin of all these property lies in the electrons. So basically electrons are behaving as tiny magnets. Okay, the reason is basically because electrons are having two motion. One is the orbital motion around the nucleus. So we know that electrons are actually going around the nucleus. Here this is your nucleus. So we see there is a magnetic moment because of that. Okay, and the second reason is spin around its own axis. We know that there is a spin that is plus half and minus half. That is your magnetic, not magnetic, spin quantum number. So that you can see in structure of atoms. Next is basically because of these two reasons, we see that there is a small magnetic moment that is coming out. Now, this magnetic moment is very, very small. So we measure this in units of Bohr magneton. Okay, so we know that one Bohr magneton is 9.27 into 10 raised to power 24 ampere meter square. So this is the unit Bohr magneton that we use for magnetic moment calculations. Next is first type of substances is actually paramagnetic substances. So we are dividing into different types of substances according to their magnetic property. So first is paramagnetic substances. These substances are actually weakly attracted by magnetic field. They get magnetized in magnetic field in same direction. So basically they are getting attracted and they lose their magnetism in the absence of magnetic field. Now, this happens due to the presence of one or more unpaired electron. Remember that unpaired electrons is very important. You can see some of the example, that is O2, Cu2 plus, Fe3 plus, Cr3 plus, etc. etc. So any substance or any atom is having unpaired number of electron, it will fall in the category of paramagnetic substances. Same way we have diamagnetic substances. Diamagnetic substances are those which are actually weakly repelled by magnetic field. Okay, so here they get magnetized but in opposite direction, and this happens because all the electrons are paired, or in the other way you can say that there are no unpaired electrons. Okay, very, very important. Diamagnetic substances, they have all the electrons paired, or you can say no unpaired electrons are present. So here we see that the pairing of electron cancels their magnetic movement. Okay, and they lose their magnetic character. Example is H2O, NaCl, C6H6. So these are weakly repelled, whereas paramagnetic were weakly attracted. So these are the two types. Then comes ferromagnetism. Okay, so ferromagnetic substances are like iron, cobalt, nickel. Okay, so these are substances which are actually very strongly attracted by the magnetic field. So such substances are ferromagnetic substance. Now what happens is there is something called as domain. Okay, so domain is actually an area which is kind of randomly arranged in absence of electric field, okay, or magnetic field in this case. So we are talking about magnetism, so that's a magnetic field. So in any metal ion, the ferromagnetic substance, they are grouped together in small regions which are known as domains. So each domain is acting as a tiny magnet. So what happens when we are not when it is an unmagnetized piece, okay, when there is no magnetic field present, the domains are rearranged, or let's say randomly oriented, and they get cancelled each other, so there is no magnetic effect. But when the substance is placed inside a magnetic field, all the domains get oriented. You can see these are small small domains. They get oriented in one direction, okay, that is, let's say, towards upward, and a strong magnetic effect is produced. So basically this effect, even if you remove your magnetic field, what happens, this effect stays. Okay, so these substances, ferromagnetic substances, can be used to make permanent magnets. Okay, so these are your domains. Even if you remove your magnetic field, it stays in the same way. Now, apart from this, we have antiferromagnetism. Antiferromagnetism is the substance where the domains are present, okay, but the domains are cancelling each other's effect. You can see this is upward, downward, upward, downward, upward, downward. So here the net effect is cancelled. So you can see the domains are oppositely oriented and cancel out each other's magnetic moment. Okay, so here there is no magnetic moment, that is antiferromagnetism. Then if these domains are arranged in unequal numbers, okay, that substances is ferromagnetic substance. Okay, so ferromagnetic substances are weakly attracted by magnetic field. You can see here also this is up, up, down, up, up, down. So you see four are facing upwards, okay, and two are facing downwards. So here the number of facing upward is not equals to number of facing downward. So this is your ferromagnetic substance. Example is Fe3O4, that is magnetite, or ferrites, that is MgFe2O4, or ZnFe2O4. This is magnesium ferrite and this is zinc. So these substances also lose ferromagnetism on heating. So when you heat them, they are arranging again themselves and they become paramagnetic substances. Okay, so that's it. This is the end of solid state. I hope you enjoyed all the sessions, okay, of solid state. And if you like, please like the video, okay. And if there is anything, comments are also most welcome. If you want to give me any suggestions in order to improve this channel, please, most welcome. Please let me know. Okay, thank you guys.